Hi, welcome to the 10th live session of Algebra 1. My name is Shauri and I am doing my PhD on processing of mathematics. So, as per the request, um, first we shall go with the assignment and weekly assignments, of course the answer has already been released. And then, if time permit, then we shall go with some concept, or if you have some doubt, you can ask me to. But do not one thing, these live sessions are meant for problem solving. So, try to use this relaxation as much as you can. Okay? It will be very much beneficial for you. So, okay, let's start. So, okay, so first we shall go with last week assignment, namely week 9 assignment. And if we end this for time, then we shall go with some quick assignment because we have not yet done that assignment 1, 2, 3. Okay. So first we go to week 9 assignment, then we shall go to it backwards respectively. Okay. So that's week 9 assignment. Okay. So the first question is, let R is equal to zxy and AMB R. Let phi M to M and R modulo N log modulus. The question is, which one, which of the following are submodels? Because which are called submodels. Okay. So the options are given as all those M such that prime is equal to 0. Option 2, option 2, all those M such that prime non-zero. Option 3, all those N such prime is equal to x squared plus y squared. 4, all those F remain such that phi is not zero. Question within these four options, we need to understand, we need to find out which one of the following is not is a submodel. Okay. So can you please tell whether I'm audible? Please confirm whether I'm audible.
Yes, you are audible.
Yeah. Can you see the screen?
Yes, I can see the screen, but it would be better if you scroll it down a little bit. Uh,
Now is it
yeah.
fine?
Yes, yes, visible now.
Yeah, yeah.
Thanks.
Okay, so first, today we have started from the
Sir, sir, excuse me.
yes, please tell.
Sir, please question. From here, is it start from here? Just
Yes, yes, right, right.
question is visible on the screen. Just let be
So
it as.
yes, so let me tell the question. So R is given to be ZXY, okay, polynomial ring but two variables, and M is given to be an R module, okay, and M and phi M to M is an R module endomorphism, basically homomorphism, okay. Now the question is that which one of the following within the four options, which one of the following are submodule of them, okay. That's what we need to check. Do you
Okay.
understand what we need to check? Do you understand that?
Yes, check.
If you have any confusion, please tell. I don't hesitate. If you have any confusion, understand the question, please tell.
Yes, sir.
Yeah. So if you have any issue in understanding the question, please tell. Or try to solve the question. Or if you have any doubt in self the question answers or the options, please ask. Try to solve. Take your time. If you have any doubt in solving the question, actually, please ask.
Sir, what was the first option? Saying M belongs to M such that it had
Yes, yes, 2. 5x not
two,
equal to 2x.
two, two M or two X.
No, okay. Here it is x, okay. So that's why both sides here it is x. Okay.
It is not. I am saying about option one. M belongs to M.
So it is small x.
Oh, okay, okay.
Are you able to do it? Are you able to solve this problem? Just let me know.
Sir, Z, what are the form of the element of R?
There is a polynomial ring zxy. So basically, any element of zxy look like summation aij x to the power I y to the power. It's a polynomial expression in both x and y.
Okay. And what is zero element? First, we need to check it is empty or not, and zero of the polynomial ring must
Can you,
be belongs to.
can you just repeat? I don't get you properly. Can you please repeat? I could not hear properly. Can you please repeat?
Yes.
Yeah, I could hear you properly. Kindly repeat.
Uh, 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 First, we need to check the submodule must be non-empty. Say a subset of the module given module must be non-empty, and it contains the zero element. Uh,
Yeah, yeah.
and
Of course, non-linear need to be checked and zero element also need to be checked.
yes.
Yeah, that's right.
Sir, endomorphism means homomorphism.
Yes, how on? What about the option one? Is it a model or is it submodel? Submodel or is it not a submodel?
Sir, here M is the abelian group. Uh, so, and characteristic of the group is true given.
Next we have group is
M is equal to 0, and if M is equal to 0, it is the least number, because if
one second,
M
one
is,
second, one second. Suddenly characteristic means the list number such that name equal to okay.
yes, yes.
How we are getting characteristic here? I mean, yeah, it's characteristic zero. Then what?
If we put M is equal to identity, then it must be 0. It may be a submodule.
No, no. I mean, there might be either it yes or no. I mean, if yes, why yes? If no, then why no? So in order to choose the submodel, what you need to do?
Actually, we need to do check our non-emptiness, and other condition is if M1 and M2 be the two elements of the M, and R be the small r be the element of capital R, then we need to check X plus R M1 plus R M2 is whether it is belongs to given set or not. If it is given to the set, then it must be submodule of that.
Yes, right. So for option one, please check it. Check those things for option one because zero is in fact zero. Zero belongs to that set for the option one, right?
Yes, yes,
So check the other two options. Check the other two conditions.
yes.
Check check. I mean, there is no point of thinking unnecessarily. You need to check whether conditions are being satisfied or not. That's all. Please check it. There is no scope of guessing. There is some way, and you need to follow the way. That's so. Whatever the other two conditions are they being satisfied for the option one? Any issue in understanding the module, please ask. Okay. If you could not understand the theories properly, please say because this problem is directly linked with basic theoretical parts. If you have any issue with the theory itself, please say. I will tell you what I will teach you the theory for. Okay. But please stay. Don't be silent. Okay.
Yes,
So in the option one, what about the other two conditions? Are they being satisfied or not?
yes, satisfying.
Yes, sir. Satisfied or not?
Yes,
Satisfied?
yes,
Okay.
satisfying.
Option one is submodel, right? Correct?
Yes, mm,
And anyway, this is nothing but a kernel of phi, correct? You must have seen the kernel of phi, kernel of some map you must have seen, right?
yes,
And kernel is a submodel. So I mean, so that's a submodel. Okay. And now
yes,
tell me, whatever option two, can option two be submodule? Try to analyze whether
no,
that.
it is not satisfying the non-empty. zero element of.
No, I mean, no, no. I mean, so you're saying that zero element does not belong to it, right? But some other element may be equal to zero, but it is not the case, so that it's not a submodel. Correct, fine, good. What about option 3?
Here xy are xy are taken from a ring from.
Yes, zxy, go that to xy. What about
No,
option?
it is not satisfying condition 2
Yeah, why?
because it is if x square plus.
Wait, I mean, whatever you get crystal.
Because it cannot be put of the given from x square plus y square, and there was a element r associated with it.
No, no, I don't get it. The thing is, you need to check whether that two conditions are being satisfied or not, right? What about the
Yes,
first condition? Is it
first one
non-empty?
is no. Yes, yes.
Okay, it is not empty. The zero element there,
Yes.
and then what about the third condition? If two elements are there, then their sum is also there, right?
Hmm.
So, is that property is being satisfied?
No.
Okay. So, is one element m1, and suppose to take another element. Now we need to check that m1 plus m2 satisfies same condition.
M1 plus we simultaneously tell M1 and one ring element plus RM2 where is not is belong whether it is.
Okay, that's okay. R L1 plus Sn2, right?
Hmm.
So R is by definition R phi m1 plus S P m2, right?
Yes.
So, what is R phi m1? R into x square plus y square m1, and what is S phi m2? X into x square plus y square m2, right?
Yes.
So what x square plus y square going out and getting almost rm1 plus sm2, right? So what are getting?
Yes.
Phi of this thing is equal to this thing. So this means what? Rm1 is m1 plus m2 belongs to that set,
Yes.
correct?
Yes. Yes.
So it is submodule, right?
Yes. Yes.
About option 3, sorry, option 4. All those x are that phi x not equal to 2x. What about this option? Think about it.
Hmm. Yes.
Yeah, think about it.
Say it is violating the first condition, because if we put x is equal to zero element, then it must be equal to 2 into 0, that is 0. But here given that phi of x not equal to 2x.
Correct. So zero element is not there. So only option one and option two, right? Understand? So
Yes, yes.
only you need to check the zero element is there, is it non-empty, and that condition three is being satisfied or not. That's what we need to only check. Understand? Oh. Let's go to the next problem. Let R is equal to Z and M. Let's find R is given to be ZXY, then and M is R model phi and psi to R model home model M. Then the question is which of the following are submodel? Although M belongs to M, such that phi is equal to minus Xn and dot dot dot. So now try to solve it. You need to check three things: non-emptiness, zero is there or not, and the last condition. That's all.
Option 1, 2, and 4 are submodules.
Okay. Okay. So why not three? I mean, can you give one example of why three is not the submodel? Anyway, okay, no, sorry. Example, consider example is quite tricky. Anyway, but your answer is right. Option one, two, and four. That's good. Fine. Why the option one, two, and four are correct?
Sir, option 1 is telling M belongs to M such that phi of x is equal to minus x phi M.
Yes, yes. Why option one is correct?
Sir, option 4 is telling psi of phi of m is equal to a such that one m belongs to m.
So that M belongs to M. This is not one. This is just M. M belongs to M. Understand?
Yes.
That's why option 1, 2 and 4. Sure, are you trying those options? Which one is the correct answer? Okay. If you want to respond it, so I hope you can solve by this those checking by yourself. Okay, so let's jump to the next problem. Consider this as a module over unequal. Now question is among the following statement or no ones that the ground module has a similar we are meaning our module one in number 3 the only automorphism here Number 4. Two. R module. Okay. So the questions are answered firstly. Consider consider Z as a module of itself, that is the Z module. Then still which of following is correct? The only R module of endomorphism is yes, empty or zero amount identity. First statement. Second statement is there are infinitely many R module endomorphism of A. Third option is the only R module automorphism. Yes, empty or identity. Fourth option is there are exactly 2 R modules automorphism. Okay, now try to understand what's happening. Check which one of the following are, are true or false. And also try to give me an answer. Please take a time, please take a while. I shall back up for some minutes. Okay. So did anybody solve this problem? If yes, please put it out.
Option 4. There are only 2 automorphisms.
Okay. Option 4. Why? I mean, please kindly explain.
This module is nothing but group homomorphism, and there are only 2 automorphism from Z to Z, which
Yeah.
is
Oh,
identity and its inverse.
yeah. Very good. Very good. Okay. So option 4 is correct, and except option 4, whatever the other 3 options. Whatever the other options. I mean, except options
Um,
yeah,
yeah, uh,
yeah, yeah. Please continue.
First option, I think, what is the first option?
First option is the only R module endomorphism if M2M are the zero map at identity map.
It's wrong, and there are infinitely many endomorphisms.
Yeah, right, correct.
That is true.
Yeah, yeah, fine. Okay, so that's the option 1 is invalid, right? What about second option? There are infinitely many R module endomorphism of M.
It's true.
Yeah, right. For the third option.
Third option is wrong.
Oh, yeah, false. Correct. Yeah. Very nice. Uh, are you able to understand the solutions? Pratim, are you there?
Sorry.
No, no. That other fellow, Mr. Supradeep. Supra, do you understand the
Yes,
calculus?
sir. Uh, I have not uh, done yet. Um,
Let's try and let me know if you have any doubt or any problem.
Sir, why was there are infinite many R module homomorphism from M, that is.
Yeah, because here M is what? Here M is Z, correct?
Hmm.
So, what are the possible P2V?
Yes, one. How many ways put the one to the other side?
One goes to any integer for
Yes,
any,
yes, yes, yes.
so that's why it's there.
Mm-hmm.
Okay. And do you understand the other options?
Yes, yes.
Okay, so let's go to the next problem. Let A be the following aspects. So let me first read the question first. So it's given that we have some matrices given, okay, and R3 is a column vectors. Now then we have considered a linear transformation. P goes to AV, okay. Now we are defining small r to the Rx and V is equal to R3. Now consider R3 as an Rx module via TA. Now there are four options. The first option is V has no R submodules other than 0 and V. Second one option is V has infinitely many R submodules. Third option is there is a proper R submodules M and of V such that V is equal to M. Fourth option, there is all submodule L of V does not admit a complementary submodule. That is, will not exist any submodule L dash as a V is equal to L plus L dash. Okay. So these are questions. So first, tell me what does it mean by considered V3 as Rx module via T. Tell me what does this line means. Anybody? Please tell what does that line mean.
Uh, ring is R of X,
Yeah.
and there is a R3 with the linear operator A is a vector space.
That is okay. That is okay. But uh, what is the module structure? I mean, what is um,
Structure of the module.
yes, right. So how the multiplication has been defined? And that is the next thing, right? So what is the multiplication?
Uh, Take an element of R of X, which is f of X,
Yes,
uh, which is A naught plus A1x,
yes,
and so on A and X. So when it is operated on a element of R3,
yes.
we consider its linear operator. So replace X with the linear operator T, then compute the product.
Fine, very nice. Good. Okay, so this is the model structure. So now with respect to the model structure, try to go with the statement whether it's true or false.
I don't know the answer for this. Actually, my answer for this was wrong.
So what is this answer first? What is your answer?
My answer?
I mean, what was your answer for this question?
My answer was V has infinitely many R submodules. And the third option.
Okay.
Sir, his second option, where are the second option? One option and third option, and yes, I have not heard you.
Yes. Can you please repeat?
What are the where are the option number two? Here I am saying option one, option three, and option last. Okay, okay.
So first, I mean, you are saying the option one, three, one, two, and fourth option correct, right? Okay. So give the argument why option one is correct. Option one is correct. Yes. Why you think the option one is correct? Yeah. Okay. So it seems no respond. I cannot tell him it's correct. Anyway, so the point is that. I mean, let uh, I mean, claim is that under this model structure, I mean, V is of V is R, V is equal to R3, right? So V is already a vector space. Okay, correct. Now the point is that so it has already some subspaces. Now the thing is, under this model structure, any vector subspace of R3 is a submodule of R3. That's all. Under this model structure, any vector subspace R3 is a subspace of R3. Sorry, submodule of R3. So for that, what I need to do? I mean to say, suppose let V1 be a vector subspace of, then V1 is Rx submodule of, and you may ask why this is so. Now the point is that if you under this model structure, if you consider those three conditions, you can see that those three conditions is clearly been satisfied. So that's why any vector subspace of V is an Rx submodule of V. Okay. Now and the vice versa. Any Rx submodule of V is a vector space of vector subspace of V. Same way you can check. There is nothing extra thing to do. Okay. Now the thing is, observe what? Observe that V is given to be R3, right? Okay. V is given to be R3. So in R3, what are the what are the subspaces of R3? What are the subspaces of R3?
Zero trivial subspace, zero R3 and R2 R1.
Yeah. So there are only four subspaces of R3. So that's why there are only four Rx submodule of capital V. Okay. So The first option, V has no submodels other than 0 and V. This is not possible because we have some non-trivial. Option 2, sorry, option 2 is that V has infinitely many R submodels. This is not also true because V has only finitely many submodules. Okay. And option 3, there exists a proper R submodel M of n so that V is equal to M direct sum small n. Now think about this. Think about this option. Is it possible? Is it true or false? Think about this. I mean, direct sum means just intersection is 0 and M plus n is V. That's all. Okay, that's the direct sum mean.
Yes, R2 and R1,
Yeah,
R2
right,
direct
right.
sum.
Correct. So option 3 is correct. What about option 4? There is R submodule A of V which does not have a complementary submodule. That is, if you take any submodule, there does not exist any another submodule whose direct sum is entire V. Now this is obviously false because if we take 0, I mean, firstly not trivial. So if you take R, then R plus R3 is equal to V. Sorry, R plus R2 is equal to V. If you take R2, then R2 plus R equal to V. Okay. So option 4 is also false. So only correct option is option 3. So that is the full argument. Do you understand?
Yes.
Okay.
But in assignment answers,
Uh,
they have given that option 4 is correct.
so one second, let me check one second. Just hold on, let me open the website. Okay, thanks for pointing out this. I will stop because I will give the structure regarding this solution. Okay, thanks for the pointing out. Next lecture, I'll update about this question. Five is that given A is the following matrix 200 120 00, and we have some same linear transformation PA R3 to R3 0 state. Okay, and let V is equal to R3 as an Rx submodule. Right. Define E1 to be 100 E2 to be 010 E3 to be 001. Now question is choose the correct statement. First option is RE1 is R submodule of it. Second option is RE2 and RE3 isomorphic to, I mean RE1 RE3 are isomorphic as R submodules of G. Option 3, V by R E2 direct sum R E3 is isomorphic to R E3 as R submodule. And option 4 has infinitely many R submodules. So thus it is almost same question as previous. We have some matrix, we have some linear approximation, and R3 is now being considered as an Rx submodule by the same map, by the map TA. We have three vectors E1 and E3. Now first question was that, the question is, you can see the question options. Now determine which one is correct and which one is wrong. Determine this.
Sir, question is not completely visible to me.
Okay. So matrix A is given 2 0 0 1 2 0 0 0 2, and the near proximity is also given, and E is an R3 which is an Rx submodule via the map. And E1, E2, E3 are the usual isolated vectors of R3. So the first question is RE1 is an R submodule of G. Second one is RE2 and RE3 are isomorphic as R submodules of G. Third one is V by R1 E2 takes some RE3 isomorphic RE3 as R submodule. And fourth one is V has infinitely many R submodules. Okay.
Yes, yes.
Good answer. or still at least one option is okay. Okay, so there is complete silence. Okay, so let me. So, so in order to first solve the question, first we need to write down what is RE1, RE2, RE2, right? So what is the set RE1? Sorry, RE1 is what? So it is R00, such that R belongs to R. Similarly RE2 and similarly RE3. And it is clear that both three things RE1, RE2 and RE3 are some. Okay, and it is, I mean, from this description it is clear that RE2 isomorphic to RE3, and for this consider the obvious natural map 0 or 0 goes to 0 0 or okay, and it is an RX module homomorphic. It is not difficult to prove directly. Okay, and so Rx is a submodule of V, so first option is correct. Second option is correct. Okay. Option 3 and 4. Okay. Now point is that V, any element is V is equal to what? V is equal to R3, right? So it is what? So it is RE1. I mean, it can be written as what? R1, R2, R3. So this is R1 of 100, R2 of 010, R3 of 001. Okay. So this belongs to what? RE1 plus RE2 plus RE3, and it is easy to check the intersection is trivial. Okay, so V, which is nothing but R3, is equal to RE1 plus RE2 plus RE3. Okay, and option 4 is what? Option 4 is here infinitely many are some models, but that is not the case because I mean, so from option 3 this implies what? V by RE1 direct sum RE2 isomorphic RE3. So this is option C. So option C is also correct, and option 4 is also correct. Sorry, option 4 is incorrect. V has only finitely many R submodels. Okay, so that's why only correct option is option 1, 2, and 3. But Ramesh, since you have pointed out some things inside the answers, so for this question I was checking the answers. So anyway, it is clear that RE1 is the R submodule. Okay, so there are some error in the answer itself. So I will link to the structure shortly after the transition. Okay. But in your the point is that option 1, 2 and 3 are the correct options. That's all. So now consider the G modules A is equal to G by 10C plus G by 10. Then N is equal to C by 10. That H is equal to a home set M in B set of Z model homomorphism from M to N. Now question is that what are the correct options? First one, order of H is equal to 100. Second one, order of H is equal to 10. Third option is order of H is equal to 30. And fourth option is order of H is equal to 2. So the question is that model is given Z10 by Z20 and N is Z30. Now we need to understand, check how many elements are there in home element. Okay. By the way, do you know what does it mean by home element? I mean, if you have not seen motion, it is the setup of Z model homomorphisms from M to N. Now try to understand what the answer will be. Or if you know the answer, please tell me. If you don't know, please also tell me. Please try and please let me know the answer. Please take your time. Let me know the answer if you have doubt in the Okay. So let's start. So here M is equal to uh,
Excuse me, sir. Hello.
yeah, yeah, this one.
Yes, sir. My electric was gone due to network problem. I have lost my connection. So
Oh,
whatever, please go and repeat them.
yeah. So this is the question number 6. So the question is that consider the z mod of m is equal to z by 10z at direction z by 20, okay, and small n is equal to z by 30z. Now let h be the home, mn be the set of all z model homomorphism from m to n. Now the question is that correct which one of the correct coordinate of h, that is number of elements inside h is 100 or 10 or 30 or 200. Okay. So this is the question.
Okay.
Okay. So first tell me, do you have any idea how to solve this question? Or have you tried this question before? Yes. Do you know how to solve this problem?
Just please scroll down the page. Sir, scroll up. It is scroll up. Okay, okay. Sir, is it 30?
Proper argument.
Hmm?
It is not. It is not 30. No, no, it is not 30. First, I mean, why you think it should be 30? First, tell me that. Tell me your case or answer.
Hmm. I am just intuitively think that it must be mapped to Z13. So a unit of the M must be it must be choice to 30. So
Okay, anyway, the answer is not 30. Now think it some different way. So what is the answer? Are you getting anything on the one side or you are not getting anything?
Sir, 1 second. I'm thinking about.
So the first thing you need to know is that if D be the GCD of M and N, then home theorem theorem is isomorphic to Z by Z. Okay, and of M1 plus M2 greater than M2 comma M, that's isomorphic to home M1N cross home M2N. Okay. Now using these two facts, can you now give the answer? Yeah, using these two facts, can you now give the answer?
Sir, scroll down that. Yes, yes. I have note down. I am noting down that. Sir, I am saying, is this class are available in recording mode?
Yes, yes, it is already there in the course portal. All links are given there.
Yes, yes.
All
Okay.
these links, all the classroom utilization are given there. YouTube link. Okay. Okay. Now using these two facts, can you just tell the answer?
Hmm? Short.
Okay, so so mm, home Z by 10Z cross Z by 20Z, comma Z by 30Z, mathematically home Z by 10Z, Z by 30Z cross Z by 20Z, Z. And by that factor, this implies is equal to how, sorry, this is equal to Z by 10Z cross Z by 10Z. Okay, so order of page is equal to 10 multiplied by 10, which is 100. So this is the argument. Okay, so does each of you understand this argument? Let me know.
Sir, excuse me, why you have written this fact and where are the proof of this fact? Is it
Uh,
in the theory class of?
yeah, what's it? I mean, the thing is, it's a well-known fact, and I think sir has done it. Okay,
o-
but
Okay,
anyway, if sir has not done it, no need to worry about. You can search this fact in any textbook. Okay, or you can, and if you have the book Damitan put in the Damitan book, this fact has already been proved in the book as
mm,
some exercise. It is proved there, or also, or else you can find over the internet. And if you could not find it in anywhere, please ask about this thing in the next live session. I will solve it for you. Okay?
okay.
Yeah. Consider now next question. Consider the Z module M is equal to Z by AZ plus Z by BZ and N is equal to Z by CZ for ABC belongs to Z. And suppose the array exists unique. Z module homomorphism from M to N. Then choose the correct options. The GCD of AC1 to GCD of BC1, the GCD of AB1, 4, 4 is there exists a unique Z homomorphism problem. So there's a four options. You need to check which one is correct. So let me give the last question. N is given to be Z by AZ direct from Z by PZ. Okay, and N is given to be Z by CZ. Okay, for some ABC inside Z. Now, suppose given that there is a unique Z model homomorphism from M to N. Now these are the four options: the GCD AC1, GCD BC1, GCD AB1, and fourth option is there exists unique. Sorry, there is unique Z-model homomorphism from N to N. So now think about which option should be correct and why. The thing is, if you first I mean, for instance, if you could not understand how to solve the situation, first go back to the previous problem and look at the facts that we have used and try to connect those facts with this current ongoing problem. Okay, try to solve this second time and let me know if you have already done it.
Yes, scroll down the page slightly. Yes, scroll down, sir. Scroll up.
Pull down, right?
Oh, yes, sorry, sorry. Scroll up, scroll up. Yes, yes. Uh, sir, here GCD of AC and GCD of BC should be 1.
Okay, that's fine.
Yes?
Yeah, that's fine, that's fine. And what about option 4? What about option 4?
Sir, 4.
Yeah, yeah. What about option?
Uh,
Look, it is known that there is a unique homomorphism from M to N. Okay, so now what about the other option? I mean, what about the reverse direction? What I mean, for that also you need to go with the last. I mean, last question, and you need to use this to that for this problem, and you some seconds ago you told that one or two are the correct option, right? So for that you have used something. Now use the same thing in order to solve question number 4.
sir, is GCD is unique of 2 number?
Yeah. No, the point is that you need to no, understand thing is you need to relate the this is equal to 1 to the uniqueness of the homomorphism somehow. And it's some kind obvious. Now you need to realize that fact. Can you understand what I'm trying to say?
No.
Yes. So suppose GCD A1 is equal to 1. If GCD is 1, okay. So this implies what? Hom Zm Zn is equal to 1. This means what? From Zn to Zn there is unique homomorphism, right? If I mean number of elements in Zn is 1 means what? There is unique element from Zn to Zn, correct? I mean there is a unique homomorphism,
Yes,
right?
yes.
Yeah. So
Hmm.
that's what it is. You have already told GCD AC equal to 1, GCD BC equal to 1. But for the converse direction, that GCD of is that two element is 1. So, I mean, what I'm trying to say basically is that you need, I mean, for option, this option 4 is nothing but showing that nm is equal to 1. So, is it true or false? Nm is equal to 1. Is it true or false? Under the given condition? And now you have already told that GCD AB equal to 1. This means what? So now, so M is equal to what? Hom ZC, comma ZA cross ZV. This is isomorphism. ZC ZA cross ZC ZV. Now this is singleton set. This is also singleton set because you have already told that GCD BC is equal to 1. So this thing is equal to 1. So there is a unique homomorphism in the reverse direction also. So that's what the argument is. You understand?
Yes, yes.
So now consider, let R be a ring and consider it as a letter model. Now we form R is a finite set, then which one the following? The first question, R is finite. Second option, considered R as writer module R and means module. cannot. Fourth is no such mean R. Okay. So R is given to be some ring and it's not here. It is consider an R is an R left module. Now consider the home RR. And it is given to finite. So now question is which of one is first one is R is finite. Second one is consider R as a right on module which and R administers finitely many right module homomorphism. Third one is R found with field. Fourth one is no such R exists. So think about it and try to do the answers. I mean, first three. Tell me one thing. So you given any random R, how you will get, how you can make some at least one non-trivial module homomorphism. When any ring R, if you consider it as R module, left R module, how you can, I mean, give one non-trivial module homomorphism for any arbitrary ring R. First, you need to understand this. So, give one non-trivial module homomorphism for any uh, random ring R.
A map to R into A. Like that is.
Yeah, so can I skip what you just said? Can you just repeat? Ramya? Okay, so if you take any R belongs to R, some any R, then X goes to R. X is a ring homomorphism. Okay, so it's some non-trivial. So now using this fact, try to understand that question. So first, okay, so let me do the answer because we don't have much time left. One second. So for firstly R is given to finite thing, okay, but R is given to finite thing. So anyway, what are the possibilities for this? I mean, so if R is infinite, so for each R belongs to R, X goes to Rx is an element of home RR. So in that case, home RR will contain infinite number of elements. So which is a contradiction. So order of R has to be finite. Okay. Second one is consider R as a right hand model. R as a finite element right model. So in order to do the part 2, you need to understand one fact that any uh, left R module homomorphism is also a right R module home. Any left R module homomorphism is also right R module homomorphism. You need to understand this. Okay. How to do this? Suppose, sorry, F R2R is a left R module homomorphism. Left R module endomorphism. And what is the right R module structure? R cross R2R. I mean, it is given obviously R1 R2 is equal to R1 R2. So thing is F is right hand module. Why? Because F of R1 R2 is nothing but what? F of R2 R1. If a left hand module, so R2 F of R1. So it is nothing but F of R1 is equal to 1 second. Sorry, what happened? 1 second. Suddenly my application crashed. 1 second. Sorry, it's fine now. Fine. Sorry for the inconvenience. Yeah, now if F is a right R module, yeah, if is a right R module homomorphism, can you see the screen? Can you see the screen?
Yes.
Okay, the thing is that I mean actually some my application is not my application hasn't stopped working, so I could not write anything now. So the fact is that any right arm or any left arm module homomorphism is also right arm module homomorphism and vice versa. Now in the question is given that R has I mean in the question is given that as a left arm module the state is finite. So those left arm module homomorphism is also right arm module homomorphism. So that state is also finite. Okay. And so option 2 is also correct. Now option 3 is R cannot be a field. Now the thing is that uh, I mean try to I mean the option that R cannot be field, this is not a correct option. So try to guess possible counter example. And of course the option 4 is not correct. At least we have some ring Z3. I mean some finite ring into what, right? So option 4 is not correct. Option 3 is option 2 is right. What about option 3? Think about option 3 and please let me know in the next live session. Okay. So for today, that's all the live session. If you have any doubt or
Hello, sir.
yes,
Yeah, Option 3 is left as thinking for
Yes.
session next. And what are the logic you have told in the past? I have not connect. Yes.
The thing is that any lefter module homomorphism is also a righter module homomorphism. Okay, by the obvious module structure.
Yeah,
That's
which is
all.
the
That's
one.
all you need to understand.
বন্ধ করতে হবে।
Sorry. Thing is, any lefter module homomorphism also righter module homomorphism. That's all you need to understand, and it is very much easy. Okay. Please think about this problem. If you have any issue, please ask me in the next live session. I will definitely discuss it for you. Okay. Okay. So that's all.
Sir, but I have a problem uh, regarding not relevant to today's class. I have a problem.
Yeah. Please,
What are we? I want to find the explicit form of the ring homomorphism from Zm to Zn, where M and R belongs to natural number.
it is
In
not.
group theory,
It is not always possible. I mean, explicit homomorphism is not always possible. Theoretically, there are z. Theoretically, there are z by GCD number of so that homomorphism. But if you
in group theory, it must be the number of homomorphism is equal to the GCD of the given to integer. And how to find it explicitly, and what are the form of the homomorphism.
that's what I have said some minutes ago. You can if you have the book Dummy Code, you can search that book. That book has explicit argument for this problem.
Okay,
They have done it
okay,
explicitly. That is where one will go. They have done it explicitly. Okay. If you could not understand, or if you could not find it, or if you could not find out anything also, please ask me in the next live session. Okay.
okay,
I'll solve it
okay,
for you. Okay.
okay.
Yeah. Okay.
Sir, I have another question about I am lacking of the knowledge of multivariate calculus. I mean, the analysis of the calculus of Rn to Rm. I have limited my
It is algebra. So
uh,
suddenly, from where calculus is coming?
which book you can suggest any book
Uh,
for
so,
preliminary ones?
so it is multivariate calculus, right?
Yes, yes, yes. Analysis. I mean, real calculus. We have did an analysis and the more depth concerning about the.
So are you going with the multivariate calculus or something
Yes,
else?
yes, yes.
Okay, so go with the book Rudin, Rudin
Uh,
reanalysis.
okay, 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 sir.
Yeah. Okay.
Okay.
Okay, so I am leaving the call. If you have any issues, please ask me the next question, or you can do it. Okay. Okay, I will leave now.
Thank you.